So hi friends, we are going to continue our discussion for the remaining part now, so part 2 now. So next chapter is chapter 4, GHG emission inventory for the company Salik in Dubai. Okay, we are discussing the case study, and this case study will be very useful for ESG learners and the students, sustainability learners also. So you see in the 4.1 consolidated statement of GHG emissions. So what is written in the consolidated statement? This is the reporting organization, reporting period, operational consolidation approach actually. So what are the emissions? Their units, types of emission, units, total emissions, GWP factor used for converting emissions to equivalents actually of carbon dioxides. So what is the total emissions in tons of equivalent CO2 emissions? So if you see, there are different types: scope 1, scope 2, yeah. Then in scope 1 itself, carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, sulfur hexafluoride, perfluorocarbons, nitrogen trifluoride. All these are given, but if you see, they are the values of scope 1, where carbon dioxide, methane, and nitrous oxides. Okay, this, you got my point. Okay, and conversion factor is given here, and total emissions. Okay, total emissions for us. So calculated. Then scope 2, this is the market based approach, not applicable, yeah, as we have discussed earlier. Location based approach, yes, this is the data available for office spaces, data centers, toll gates. Okay, toll gates. So total emissions, scope 1 and 2, it is written here. Okay, adding together this and this one. Okay, so total scope 1 and 2, this is the tons of carbon dioxide equivalents. Now carbon financial instruments, you see the certified emission reductions, 715, yeah, CERs. So there is a very important note here. We all students or learners should understand about how the GHG emissions are calculated using GWP factor. It's written here, but this has been taken from IPCC's 6th assessment report, SAR, okay, of IPCC, and for the purpose of this inventory, only carbon dioxide, methane, and nitrous oxide emissions from fuel consumption are included in scope 1. Other greenhouse gases like hydrofluorocarbons, sulfur hexafluoride, perfluorocarbons, nitrogen trifluoride have been deemed negligible in this context. Also, GWP value shown in the column in tons of CO2 equivalent per ton of individual greenhouse gases. Next comes 4.1.1, the data sources. Okay, so what are the scope 1 emissions from data sources? Like as Salik has said that they are operating 2 vehicles. Okay, and for the year 23, scope 1 emissions have been quantified based on the actual operational data collected 3 to 4 month period, specifically from September to December. This data encompasses critical parameters like mileage, distance traveled, fuel type, fuel consumption associated with the company owned vehicles. Very important as we are talking about the scope 1 emissions. Since the company acquired the vehicles in September 23, please remember, acquired, the analysis was conducted using the data available from that month onward only. Okay, ensuring the accuracy of the emission report. It's also important to note emissions from sources other than company owned vehicles are deemed minimal, and further you can see in the section 3.1.1. Scope 2 emission data source. Of course, scope 2 emission calculation for office space, server room are based on actual operational data collected from October to June 24, October 23 to June 24. As following Salik's move to new office at Festival Tower building in September 23 actually. So electricity consumption data was only available for the last quarter of that year. Why? Because they moved to new building. Establishing a baseline also. So please remember, this is very important. Establishing baseline that time. So to estimate emissions of the office space, average monthly data from January to June was leveraged and extrapolated to account to the months of July to September 23. Means a consumption pattern based on recorded seasonality and temperature also. So it is then annualized to provide a full year estimate also. So this assumption follows more accurate estimation of energy uses, reflecting expected operational and energy consumption patterns, and also documented in the report to ensure transparency in line with 14064 and GRI protocol principles also. As the company is now independent entity, it is previously managed by RTA, Road and Transport Authority, until September 22, which include oversight and tollgate operations. So consequently, some of the tollgates still share consumption meters with RTA equipment. So this is also very important point. So the shared metering makes it challenging to directly measure the specific power usage of the individual toll gates. Now, to address this, power consumption was estimated by comparing these shared meters, toll gates, individual meters actually. Now, again, scope 2 emission for SAB, building and traffic management data centers, ownership lies with RTA, so however, maintain operational control over designated equipment. Since these data centers are shared, and isolating electricity consumption specific to Salik's operation is challenging actually. So they have highlighted clearly. So for the scope 2 emission assessment related to electricity uses in these data centers, focus was solely on Salik's equipment and servers. Then electricity consumption data was gathered from quarterly preventive maintenance reports providing. So these are the data sources, quarterly preventive maintenance reports. Also used to calculate monthly average, allowing scope 2 emissions for the full year. So you can see this very clearly. Okay. As separate utility bills for the data centers are unavailable, this methodology provides a reliable estimation despite the challenges posed by the shared metering. So comprehensive overview of the emission sources provided in 3.2.1 of this report. We will see that. This is very interesting and important also. What is the quantification approach adopted by the company? So 4.2.1 methodology adopted. What was that? So quantification approach designed to effectively minimize uncertainty in the assessment of GHG emissions, and also to identify potential reduction opportunities we want to identify. So what are the two different regions, like to effectively minimize uncertainties and to identify potential reduction opportunities. So the majority of Salik emissions are derived from the use of fossil fuels, purchase electricity, as well as also. To promote consistency, accuracy, reduce uncertainty in quantification, the methodology involved was multiplying GHG activity data by appropriate emission factors actually. So if you see this, GHG emission is equal to activity data multiplied by emission factor and conversion factors also. So this is in accordance with the industry standards. Here, then GHG activity data. Basically, to effectively quantify emissions and identify removal opportunities, the company has implemented a decentralized strategy for the selection and the collection of GHG activity data. In this approach, establish requirements of the chosen quantification methodology, ensuring that accurate and pertinent information is collected to facilitate effective GHG management. In the initial assessment, data collection was conducted through coordination with various teams at Salik. Various teams coordination. So it is clearly identified, internal stakeholders involved. The procedure developed for data collection, very important to know, students and learners. The procedure was developed for this data collection system. During this process will lay strong foundation, and also companies committed to enhance data collection efforts, such as design comprehensive data collection protocol to ensure accuracy. Also proactive approach to improve reliability of the reported GHG emissions, capacity to identify effective emission reduction strategy. So if you see the scope 1 2, So fuel consumption data, mileage data were collected from the public relations team, PRO team. So who are the stakeholders involved in this, and also the CEO's office to account for direct emissions. Then scope 2, data on electricity consumption was gathered from various sources like office electricity consumption was obtained from the QHSE section, and toll gate electricity uses were collected from the toll engineering team actually. Very important, these two sections. Then next is electricity consumption for data centers were reported by Salik's IT sections. So again, toll engineering team and the RT team also. Then very important, emission factors. So the calculation of GHG emission incorporate uses of specific emission factors to ensure accuracy and alignment with the ISO 14064 standards. So to account this emissions, we particularly from company owned vehicle. So this is very important. Utilizing DEFRA emission factor was employed, and so basically DEFRA, as we discussed earlier in earlier videos, that Department of Environment, Food and Rural Affairs, and which is again have a guideline for emission factor. And for scope 2 emission, the grid emission factor was utilized. So these two important reference sources. Okay. You can see this. So these emission factors were sourced from DEWA's publicly available reports, DEFRA's official greenhouse gas conversion factors repository, ensuring data's reliability and transparency. So both the links are given here. Okay. So fuel used for transportation, electricity generation. So emission factor references are given here. The next very important subject is global warming potential factor. So in this report, you see emissions calculations are focused exclusively on carbon dioxide, but other than carbon dioxide, methane, nitrous oxide emissions also resulting from fuel combustions. Emissions from HFCs, SF6, PFCs and NF3 have a very negligible amount. So as these are not generated by the combustion of petrol, are typically linked to different industrial processes and applications. So GW factors applied to carbon dioxide, methane and nitrous oxide are detailed in the consolidation statement, which was in section 4.1 earlier. We have discussed this. These factors are sourced from Intergovernmental Panel on Climate Change IPCC 6th Assessment Report AR6. 6th Assessment Report AR6 over a 100-year time horizon actually. Also ensuring that the calculation align with the UK's government GHG conversion factors as per DEFRA for company reporting purpose. Then 4.2.5 GHG management system and data quality assurance. So the company has established and implemented a comprehensive information management system for GHG as part of their inaugural assessment program actually. So it is ensuring compliance with the principles and requirements of 140641 standards. Okay, first standard. Then aligns with the intended use and objective of GHG inventory. Incorporating routine and systematic checks for what? To validate the accuracy and completeness of the inventories also. Also documents and archiving pertinent GHG inventory records, including details of information management system. So very strong system is available. The data related to GHG emission and potential removal reduction opportunities are meticulously maintained, recorded in controlled documents. Controlled documents, please see management information system. Also information derived from the bills, fuel invoices, estimation based on equipment load. So all the reference details are available as an evidence here. So you see, so what is the Salik's inventory approach? You see, they defined the organizational boundaries, identified emission sources, collecting data and calculating emissions, right? Data for energy, for other emission factors, they are calculating. Then they have set the reduction target as per SBTi and UAE goals, also engaging the stakeholders. Then developing a climate strategy, basically implementing energy efficiency and renewable energy transition initiatives. Then public disclosure and continuous improvement. Also in this approach we see GHG report for public disclosure and future improvement program. So this is GHG inventory approach for the company. In 4.2.6, the data collection, what is the structured approach? This was adopted by the company for the selection and collection of activity data, as outlined in table 5 only. Also to ensure the accuracy and reliability. So the data collection process, which involves gathering activity data for various sources like bills, preventive maintenance reports, and fuel receipts. Very important evidences: utility bills, preventive maintenance reports, and fuel receipts. So this information is collected at consistent intervals, such as, important guys, so please remember, quarterly or yearly, depending on the source type and associated emissions. So by maintaining a regular schedule for data collection, the report aims to provide a comprehensive, so regular schedule they are collecting the data for greenhouse gas assessment emissions, also reflecting rigorous data collection standards to robust GHG analysis. So please mark this table, very important, okay, to understand the selection and collection system of the GHG activity data. So is the serial number, GHG source type, like company owned vehicles, office space, data centers, so which we have already discussed in the reporting boundaries, and the activity data like petrol consumption, source will be fuel receipts, vehicle ownership card, which we call mulkya, right, and the data collection frequency is yearly. In the office space, if you see electricity consumption, DIVA bills, from DIVA bills, and yearly they are doing this collection. Data centers, again electricity consumption from maintenance reports and yearly. Toll gates, electricity consumption from DIVA bills, and this is collected quarterly actually. Then how to select the emission factors? So UNFCCC clearly defining an emission factor is the average emission rate of a specific gas, greenhouse gas, for a particular source basically, and it's related to the units of activity. So these emission factors are essential for calculating GHG emission from different sources, okay, from different sources. So let's see, as per ISO 1401 clause number 2.7, emission or removal factors are described as link between activity data and the GHG emission removal section. So in the context of GHG emission factors for companies, Salik, these are determined by considering following criteria. Very important to remember. These are derived from a recognized source like DEFRA and DIVA emission factors, suitable for the type of GHG source we have, up to date in time to calculation at the time of the calculation, also account for quantification uncertainty, and are calculated to ensure accurate and recordable results aligned with the intended use of GHG inventory. So the fossil fuels and energy sources like petrol and grid electricity from DIVA we are utilizing. Next important part is how to do the calculation for GHG emissions. The calculation conducted in accordance with the ISO 14064 as identified earlier, in line with 6.3 clause number of requirement for calculating greenhouse gas emissions and removals. So basically activity data are utilized to quantify emissions. Then we see how GHG emissions are determined by multiplying GHG activity data and appropriate emission factors. So if you see the calculation, this we have inventory category, scope 1 and 2, emission source, and we see the quantity of tons of carbon dioxide equivalents, right? We have seen earlier the in the table. It's emission analysis basically, as we know the reporting period 23 financial year, the report details the total greenhouse gas for company, scope 1 2 emissions, also highlighting scope 1 emission constitutes a minor portion of overall emission profile actually. Scope 2, principal component of total greenhouse gas emissions, originating from 3 primary sources like office space, data centers, and toll gates actually, where toll gate represent the largest contribution to scope 2 emissions, followed by the data center and office space. And distribution underscores the significant impact of organizational infrastructure on Salik overall emissions footprint. So we can say collectively, comprehensive assessment of scope 1 and 2 emissions, offering a complete overview of Salik's greenhouse gas emissions, like we see here. Total GHG emission for financial year 23, scope 1, scope 2, and total these two add together, and this will be a total emissions. So we can see here the pie chart for emissions, scope 1 and scope 2. And you see in table number 8 here, source of emissions, office space, data center, toll gates, and the breakdown is available here. Total emissions, scope 2 emissions are given here, you see. So basically this is 38%, this is 6%, and toll gates 56%. So you can see the breakdown of emissions, scope 2. Then we go for 4.4, uncertainty analysis in inventory. This basically, uncertainty in emissions inventory arise from both the variability in the emission factors, also the associated activity data. Now the company aims to enhance the reliability and transparency of its reporting with in accordance with the or compliance with the 14064 standard. So the focus has been placed on capturing uncertainties in scope 2 emissions arising from a combination of actual and estimated electricity data. So in this methodology, employed integrate both statistical and systematic approach to comprehensively assess and address the data variability. So what is the assessment of uncertainty here? You see, scope 1 emissions are derived directly from the fuel bills. So please understand, data is coming from the fuel bills, providing precise, reliable data with minimal variability. So measuring, no further assessment of uncertainty is required. Similarly, you see the scope 2 emissions where we are getting data from electricity consumption at the office space like bills. So electricity consumption at office space, data center, and toll gates. Involves some uncertainty due to nature of data collection and estimate techniques employed actually. So data we are getting from DIVA's grid emission factors. For emission factors, analysis include assessment of uncertainty for the emission factor grid and also ensuring a thorough evaluation of both activity data and emission factor variability. So let us see one by one. Office space, the electricity consumption data for office space was obtained from the combination of actual measurement and extrapolation actually. So uncertainties, why? A weighted average approach was utilized, reflecting the proportional significance of actual data compared to estimates. Okay, so the estimated uncertainty of 8% reflects a combination of actual and extrapolated data in the office space case actually. In the data centers case, electricity consumption is challenging to measure directly due to, as we discussed, shared facility with RTA. So as a result, consumption estimates were based on quarterly reports and preventive maintenance logs. So two sources actually, quarterly reports and preventive maintenance logs. So this approach was including assessing uncertainty through statistical methods that evaluate data variability and consistency. Also considering systematic uncertainties, which are accounting for potential measurements, inaccuracy, and data handling errors. So high uncertainty of 17%, basically 24.46 tons of carbon dioxide equivalent, result from limited sampling and high variability. So this is suggesting that data improvements could significantly reduce uncertainties. Next, for toll gates, electricity consumption estimation introduce uncertainty because of lack of individual metering and reliance on similarly based assumptions actually. So lack of individual metering and reliance on similarly based assumptions. So while direct measurements are obtained from majority of the gates, assumption had to be made for few others by comparing them to similar gates. So this approach basically introducing variability in the estimates through the reliance of assumption, highlighting areas of potential improvement in the future data collection. So uncertainty of 8%, which is 18.54 ton carbon dioxide equivalent, which was recorded basically and primarily driven by estimation methods and metering challenges. So total emissions, this with the methodical scrutiny identifying 11.4% uncertainty in total emissions. So to align ISO 14064 further refinement in measurement process, scope 2 sources advisable to mitigate those uncertainties. So uncertainty values for scope 1, 2, it is very well put in the table, percentage and amount of the tons of carbon dioxide. Base year GHG inventory. So company has taken a foundational step towards effective GHG management and performance enhancement. So first assessment for the financial year 23. This is representing the base year also for GHG emissions, capturing data for reflecting company's typical operating profile actually. So by defining the baseline, company sets the stage of monitoring progress, benchmarking with the future improvement against clearly established management objective. Also, data collected in this base year provides a critical benchmark, allowing for consistent comparison also with future inventories. Also, this structured approach underscores Salik's dedication to transparency and strategic commitment also for sustainability performance. Okay, friends. So we'll see the remaining portion in the next part 3.